In the first video, we looked at this table right here, and we were asked the question, well, actually, it asked us to explain how a student can know, which we did, what kind of relationship this is. We found out that if we took the third difference, we found out that it was constant, so we knew it was cubic. So sometimes the question also asks, well, what exactly is that equation? What is the function that would give us these values in the table? So another way to look at this, if you're a visual learner, this might help you out. Another way to look at this is by looking at a graph. So here we are in Desmos, and I already put in all the numbers into my table. My -2, -1, and 0 are on the bottom right here. But what we're trying to do is we're going to try to write an equation right here that gives us a line that'll go through all these points. Now, right here I only see 1, 2, 3, 4, 5. Actually, no, 1, 2, 3, 4, 5 of the points, but we have more points there, and that's because if we zoomed out more, we would see the other points. They're just way up there. I don't know where the other one down there. Oh, our lowest point down there is just -25, which is right there. Okay, so here I zoomed in all the way, or not all the way, but this is just kind of the home screen right here. How are we going to find that line? And so what we're actually going to do is we're going to look at the template for a cubic function or a cubic equation, and we're going to use that template to create equations to find the A, the B, the C, and the D for our line. So I'm going to go ahead and type this out here. AX to the third power, and we have BX to the second, plus CX plus D, and it looks like I forgot a plus sign right there. So put a plus sign right there. So we're looking for all of these. Alright, now it gave me a slider here so I can change them like this. I could change the value of A just by doing this sliding thing, but I can also input a specific number like 5. And so let's go back to our other screen and see if we can figure out what exactly is A, B, C, and D, so that we can draw a line that gives us these values, these ordered pairs. Okay, here's our template. I just erased other stuff and threw this down there. This is our template that we did in example 3 out of lesson 1. And in this example, we looked at the template, the general form of a cubic expression, and we plugged in these x values, 0, 1, 2, 3, 4, and 5. When we plug in 0, those terms go away and we're left with D. If we plug in 1, 1 to the third power is just 1 times A is A. 1 to the second power is 1 times B is B. And so that's how, and we kept going, we plug in 1 to that one also, and so we got this expression. If we plug 2 into it, 2 to the third power is 8. 8 times A is 8A. So we have these expressions after we plug in these numbers. Then we found the first difference. We went the bottom one minus the top, and this is what we got for the first one. Then we went that one minus that one. We got the second one in the first difference column. And then we found the second difference and the third difference. And in the third difference, we found that, oh look, we finally have the same number, just like what we have up here. But here we have actual numbers and not just expressions, because up here we know what the equation is. Well, actually, that's what we're looking for, and here we don't. So what we're going to do here is we're going to use these templates right here to make up equations. So since the third difference here equals 30, and the third difference right here is 6a, we could set up an equation to say 6a equals 30, and we could find out what 30 is. I'm sorry, we can find out what a is. And so we divide both sides by 6, we get a equals 5. And so we got a 5 for a. And actually, I'm going too fast. I skipped the most obvious letter to find out of all of them. If you guys look right here, if we plug in 0, we're left with D. All the terms with an x value get eliminated because 0, anything times 0 is 0. So we're left with D. So what did we get up here when we plugged in 0? We got a 3. So that means the D right there is a 3. So we found the D, we found the a. Now we just have to find 2 more. Now we have to be careful when we're using the template because over here we started with our x values at -2, but right here we started at 0. So anything over here on the right that we got from -2 and 1, we gotta ignore of right now as we're trying to make our equations. And so we can't get that 0, that 2, or that 30 right there. So we're going to not look at those. Actually, let me redo that there. So that's going to go like that, that, and then we're going to just scribble these out right here. Okay, so we're just looking at these numbers for the third difference, which doesn't matter, it's the same as up here. But for the second difference, our top number here is 32. And the reason why I'm pointing that out is because when we look at the second difference over here in our template, we have 6a plus 2b, and we get that by doing the 0, 1, and 2. So we're going to say 6a plus 2b equals 32. Or we can say 12a plus 2b equals 62. Or so on and so forth. I think you get the picture. So let me go ahead and set that one up. So we're going to say 6a plus 2b equals 32. Because that number 32 and 6a plus 2b line up with each other. Those are equal. And since we know what a is, we could plug 5 into that and find out what b equals. So that would be 30. When I subtract 30 from both sides, I get 2b equals 2 and b equals 1. So now I have the a, the b, and the d. To find c, we're going to go to our first difference, because in our first difference we have expressions right here with a's, b's, and c's. And we know a and b are, and so it doesn't matter which one we pick right here. I'm going to pick this one up here because that one has the smaller numbers to work with. And that is going to equal 2. So let's set it up. We have a plus b plus c equals 2. We know that a is, well, that's not a good spot to write it. So a is going to be 5, b is 1, and c is what we're looking for. So this is going to be 6 plus c equals 2. And if I subtract 6 from both sides, I get -4. Alright, so now we have all of our numbers, and so now our final equation looks like this. We have y equals 5x to the third plus 1x squared, and I'll have to write the 1, plus, actually let's do minus 4x, and then plus 3. I didn't minus because we would say plus -4, but this is a shorter way to write it. And so that's how you find the equation. So let's go ahead and go back to our graph and see if this line right here hits all of our points. Alright, we already got the 5 in for the A, and then for the B we already have the 1. For the C we had -4, so I'm going to plug in -4 right here. And then for the D, I'm going to make that into a 3. And look at that. Our line goes straight through all of those points. Doesn't matter how far we zoom out. We're going to see it hits all these points, which is cool. That's our equation. So I'm going to zoom all the way back in just so we can see the curve, because that's where the function looks kind of neat. Now, I hope this didn't confuse you like how I wrote it out right there. I could have just deleted the A right there and put a 5, deleted the B and put a 1 right there, and then that would be a -4, and then a D is a 3. It's the same thing, except now I don't have sliders. I can't just change the A, B, C, and D. Alright, so I hope that helps you guys understand how to find the equation of a relationship.